The topic we want to cover today is combining like terms, which also covers the concept of adding and subtracting polynomials. So the first thing we want to make sure we understand is, what does it mean to have like terms? If you take a look at the expression 2x plus 5x, you previously learned in factoring that I have a common factor of x. So I can factor out the GCF of x and am left with the mathematical statement 2 plus 5. Well, 2 plus 5 obviously can be combined into 7x. If I were to take a different example, 2x squared plus 5x, again, my common factor is x, and I am left with the statement 2x plus 5. Well, the problem is 2x plus 5, the 2 has a variable attached. They're not just numerical statements, so I cannot combine the two of them. So the way to look at like terms is that they are terms that have the same variable or variables, and each variable has the same exponent as its matching partner. So let's look at a couple of examples to determine when I have like terms or not. Well, similar to what I did here, 3x squared plus 2x, these are not like terms, not only because of what I showed before with factoring out the x and what's left over. What we just simply see is that no, they are not like terms because one x is squared and the other is not. So combining them would be a violation of the order of operations. In the second example, yes, each of the variables are squared, but no, they are not like terms because one is an x and the other is a y. Going to a third example, 3x squared y plus 2x squared y squared. Again, it's no, because even though they both have x and y, even though the x squareds match up, the y parts do not. No, because one y is squared and the other isn't. And then finally, 3x squared plus 2x squared, that is yes, and the result is 5x squared. Key point is you add the exponents and carry over the variable or variables. Again, why is that the case? Because I can extract an x squared from each. I'm left with 3 plus 2, which gives me 5, and I write it as 5x squared. Remember, we call the 5 the coefficient. Standard form of writing any term in math is the coefficient, followed by the variables in alphabetical order. Next question is, what if I had 2xy plus 3yx? Are they like terms? Well, hopefully you'll remember that I can change the order when I have all multiplication or all addition using the commutative property. So I can rewrite 3yx as 3xy, which is the more standard form to put it in alphabetical order. This makes it very clear that they are like terms and they combine to 5xy. That's why we ask students to put the variables in alphabetical order so as to avoid making a mistake of not seeing like terms that really do exist. Now, if I have a more elaborate statement where I am adding, and we'll start with addition first, two polynomials. So let's say I'm adding 3x squared plus 2x minus 8 with negative 6x squared minus 8x plus 2. Well, since it's addition, most students are comfortable with doing addition. What the suggestion normally is to link up the like terms. And one of the suggestions is to take each of the like terms, so my x squareds, and enclose them in some sort of geometric shape, making sure to pick up the sign to the left. And now I know those two are like terms. I know the ones with the x are like terms, and then just the constants are like terms. Since it's addition and most students are comfortable with addition, I can then now just combine the coefficients to get my answer. Okay? Where students have fallen into a little bit more difficulty is when it involves subtraction. So let's say I have 2x squared plus x minus 3 minus x squared plus 3x minus 5. Well, the problem that many students encounter here is similar to the problem you have with subtracting signed numbers. So if, for example, you had 10 minus a negative 3, students were taught the keep change change method, keep the first term, change to addition, and change the sign of the second number so that you would get a 13 here. Well, we want to put this in a little bit more sophisticated terminology in that we keep the 2x squared plus x minus 3. And what we are doing is distributing to the second polynomial a minus 1. What you'll notice now is when I do this step, my parentheses disappear. So now I have negative x squared minus 3x and plus 5. One of the things you have to be careful about is to make sure you distribute the negative sign to every term inside that second polynomial. Now I can do my combination as I did up top, putting my geometric figures around my like terms, picking up the sign to the left. So 2x squared minus x squared is just x squared. Remember, if your coefficient is 1, it's not necessary to write it. If you do, that's fine. X and a minus 3x minus 2x minus 3 plus 5 is a plus 2. Now, what students also have to be careful about with subtraction is the following couple of scenarios. I don't really want to call them word problems because they aren't word problems per se, in that there's a significant amount of explanation going on. But let's take the following example. If I said, what is negative 2x squared minus 3x plus 8 subtracted from minus 5x squared plus x minus 6. Well, this is where you have to be careful. If you thought about it numerically, if I said, what is 5 subtracted from 8, you would know that that means 8 minus 5, or 3. Well, I want to take this first polynomial away from the second. So I do not write the mathematical statement in the order as they show up, but in the following order. Now I distribute my minus sign, and I combine my like terms. I want to make sure I pick up the sign to the left. That's very important when you have a minus to the left. So I end up with negative 3x squared, a plus 4x, and a minus 14. Now, let me contrast that with the following statement. Here we said, what is this polynomial subtracted from that polynomial? Another way to state this type of problem is, what is the difference, sorry for the handwriting there, what is the difference between negative 3x squared plus 10x minus 12 and 5x squared minus 2x plus 3. Now, because I want to know what's the difference between this polynomial and that one, I do not need to change the order. It will go as written in the original problem. I will distribute out the minus sign. And I should not have my parenthesis there, but there. And now I can combine my like terms. So negative 3, negative 5, 10x2x, and negative 12, negative 3. So the key couple of points with combining like terms is, number one, you have to be absolutely certain that they are like terms in that the variable parts have to be identical. Although they're called like terms, the variable parts have to be identical to each other. Next, when you do combine like terms, make sure you add or subtract the coefficients and carry over the variable parts. And then number three, if you are subtracting polynomials, the recommendation is that you change from subtraction to addition by distributing the negative sign to all the terms in the polynomial that is being subtracted.